Okay, so from yesterday, we just briefly got into these types of reactions, and I think, excuse me, want to do a little clarification on that. So from prior knowledge, if this was a decomposition reaction, okay, what's going to happen on the right side?
It'll separate, so it'll be CO plus Cl2, right?
Okay. Okay. So then this is where I think we kind of started to go sideways, because these are just a little bit different than single replacement and double replacement reactions, okay? Because what we see happening here is we want to start putting some of the charges in, okay? So then, well, I'll let you get that caught up,
So
which
what
really
size-
shouldn't take very long. Sorry?
What things have a 2 next to it? So like, chlorine has 2 and oxygen has, or
If
hydrogen.
they're gases or halogens, but not noble gases, because they're stable. Okay, so then once we put these charges in, we would always say go by your negative charges, okay? Which means, where would we start here with this cobalt-3 chloride? Okay, so -1, but we got -3 total,
And then you put +2 next to the cobalt.
okay? And then once this decomposes and gets to this side, okay, what happens to both of these here?
They have a charge of 0.
Okay? And then I think this is where, again, we started to go sideways. And that's just because this is brand new. Because what we see happening here, this cobalt, if this is +3, I think this is where we went wrong yesterday. If this is +3 here and 0 on this side,
It'd be oxidation.
it's
Bit loss.
gaining 3 electrons.
So that'd be
Okay,
reduction.
so that is reduction. See, that's where we went wrong. Yeah, well, not we. That's where I could say I went wrong yesterday. That's why this is what sets these apart a little bit different, because, okay, so what we could say is this is gaining electrons. So when that does, okay, we call that reduction.
And then chlorine to the chlorine is.
So then here,
Wait.
okay,
Okay, I'm confused.
see, this is where we're trying to clarify that from yesterday, okay? We don't really want to say it's reducing in charge. Sometimes you can say that, but it's better to see what's happening here. So we have a total of +3, so that must mean that this has 3 more protons or 3 less electrons, whichever way you want to look at that. That once we get over to here, now it doesn't have any. So therefore, it gained electrons. We don't have to know why, we don't have to say how or anything to that nature. We just want to know that it went from +3 down to 0. Okay? So then when that is reducing, you could say it's gaining electrons. So, and again, in certain cases, if you say it makes more sense to say the number's getting smaller, which it is, but to me, it's best to see what's happening with our electrons. We got 3 less over here, so therefore that must mean we gained them. That is a reduction portion. So then when we look at the chlorine then, okay, as that's over here, kind of, this is oxidation, because now it's getting closer towards 0, so it's losing these electrons. So then this is, as you said, oxidation. Okay? So does that maybe did we clarify that? Is that a little better than yesterday? For maybe some people, better than yesterday, maybe some about the same, maybe some a little worse. But again, just think of the first time when you learn a new part in music, whether it's an instrument or singing or a new part in a play or in new movement in football or basketball. That first time that you see that, it might be a little rough. And there's nothing wrong with that. That's how we grow. That's how we learn. Okay. So then, since this decomposed, the last thing we want to do is balance that, which means who gets 2s and who stays as 1s.
Chlorine and cobalt, or no, the one on the left, you put 2 in front of it.
Okay, which we have to because we have an odd number of chlorines because these come in pairs. That's the way you want to look at it. Now we got that up to an even number.
So now you put 2 in front of cobalt and 3 in front of chlorine on the other side.
And now we got everything balanced. That's right. Okay. Front row, are we good so far? Middle row, back row. All right. So then, without any further context than this, okay, what reaction does that look like to you?
Synthesis.
That looks like a synthesis. So then, that must mean these two come together, which they do. Okay. And then upon doing so, do we need to change anything on that side?
Yes.
Yes, we do. Because this is -1, that is +2. The least common multiple then is 2. 2 divided by 2 is 1. 2 divided by 1 gives you 2.
So you don't have to balance it out.
That is balanced. So then now let's look at what we see happening. So this is +2, that's -1. This was 0 over here. This was 0 over here. So, and another way of looking at that is these reactions are what we call reversible. And when you do that, not only are you reversing one side of the equation to the other, but you're also reversing the processes, if I said that correctly. Is process its own plural? Is it, if it's two process, is it two process or two processes?
Processes.
Two processes. Okay. Two processes.
Yeah.
It just sounds funny maybe when some people say it as opposed to others. Okay. So then again, let's look at what we see happening. Okay. What did the magnesium do? Did it gain or lose electrons? It lost them.
What? It's because you need +2 to get
Yes.
electrons back. So it lost.
Right.
To get those.
So what happens is this lost, and then what process is that when electrons are lost?
Reduction.
When they're lost.
Oxidation. Oh.
So this is oxidation. And then this number, okay? So chlorine, did it gain or lose electrons? It gained electrons. And when electrons are gained, we call that reduction. So, and I understand, that's what makes this confusing. Because here we have a metal that went through reduction in what we call a decomposition reaction. Here we have a metal that went through oxidation, but it is not a decomposition. It is a what type of reaction?
Synthesis.
It's a synthesis. So that's what we mean. These reactions are what we call reversible, because we could say magnesium chloride could then decompose to magnesium and chlorine. So if that's the case, this one is gaining electrons, because when it gains then we say that is reduction. And then in this case, this one's being oxidized because it's losing electrons. Okay.
Can we do combustion reaction?
So when we just do combustion, we're not worried about putting the charges, what's being oxidized, what's being reduced. We're just saving that for single and double replacements, and then these types. So if it's a combustion reaction, all you need to do is finish it and balance it. You still want to see those?
Yep.
Little unclear about them?
Yeah.
Okay.
We do combustion and then a double. No, do we already do double? No, you Let's worry about combustion first. Never mind.
Okay, so I'm just going to pause this for a moment. I was just announcing I need to keep these up here for the afternoon session. So what we can do is let's, what do we say, rip the Band-Aid off, just say let's just, have you ever heard that before? Yeah, let's just rip the, because how many of you are scab pickers? You have a scab, you reach for it, and then subconsciously, does there a small voice in your head that say, stop that, or you shouldn't be doing this?
Yeah.
You don't hear that inner voice?
I do. There's a voice that goes, keep going. Yeah.
Oh,
It feels so good. Rip it off.
well, maybe and maybe not. So what we mean by this is, okay, I'll pause this again because I need to do a little thinking here on how I want to implement this. Okay, so here's two different types of combustion reactions. And how do we know that this is a combustion reaction other than us telling you this is combustion?
It's got
Just
carbon.
tell.
It's got carbon and oxygen in it.
Well,
It's got
yeah,
hydrogen, it's got oxygen.
it's what we call a hydrocarbon, like octane or diesel fuel, which I believe with diesel fuel is that maybe 9 carbons. I think diesel is just a little heavier than gasoline, if I'm correct. So, right. But when we look at gasoline, we say octane, so that means how many carbons then? 8, okay? So our point is a hydrocarbon, hydrogen, carbon, okay? That's our logic that this is a hydrocarbon. And when hydrocarbons combine with oxygen, what do they give off as byproducts? Every time.
Carbon monoxide.
Carbon dioxide. Is that it? You have to have some hydrogen in there somewhere.
H2O.
Okay? So if that's our byproduct in this top reaction, it's certainly going to be the same byproduct in the bottom one. Okay? So just at first glance with this, would you rather balance the top one or the bottom one?
The top one.
Okay?
Top one because it has even numbers.
Okay. Nice even numbers. I like that.
Is
So
that wrong? Is that the wrong answer?
depends from your point of view with what type of experience that you have.
Okay, give us a point of view why the bottom one would be better.
Okay? This one is the better reaction to balance. Okay? Because these are alkanes. Okay? That's what we mean. That's what we were saying from a certain point of view. We would say that if these are alkanes, which they are, even though this number's bigger, okay, you're going to want to balance this one instead. What we mean by that is, otherwise, when you look at this, you're going to say, this is how we think you would approach it. You're going to say, okay, you've got 4 carbons here. Well, that's simple enough, okay? That balances out your carbons. Now we want to look at your hydrogens, okay? So you've got, and I understand we've got to deal with our oxygens, but that'll come later. You've got 10 hydrogens. How do we get 10 over here?
Put a 5 there.
Okay, so now everything's balanced except for your your oxygens. Do we have a problem? We have an odd number. Okay? Now, for higher order of thinking, you could do this. You might do this in college. Okay? You might do that. I really don't know. But there's actually a better way. Okay? And we actually taught you this when you were freshmen.
Well, yeah, you can split the hydrogen and oxygen, can't you?
In certain reactions, certainly not this one. Well, you could, but it's just going to make it more difficult.
That's unnecessary.
It's totally unnecessary. That won't help you. That's logical. You're close. And it's not that you're going to multiply everything by 2. There's just one aspect that's going to be multiplied by 2. Nope, not the right side. Is this one of the things you want to try to remember, or just we're not going to remember?
Yeah, I just want to know.
Okay.
Is this going to be needed or not?
Mm-hmm.
Okay, yeah.
Yes. So if we're looking at alkanes and that number is even, you're going to want to double that right away. Okay? So once you do that, what do we have to do with our carbons then?
2.
You can put a 2 there.
I want to put a 6.
No, I don't think you want to put a 6 there either.
Put an 8.
You want to put an 8 there. So why is it 8 and not 2, 3, or 6 or whatever it was you were saying?
It's 2 times 4.
Because 2 times 4 is 8. Okay? So that's why you got to put an 8 there. Okay? Now let's look at our hydrogens. Here we can do that same process and say now our hydrogens are balanced. Okay? Oops, nope. 2 times 10 is what? 20. That's where we goofed. So then we got to put a 10 here. Now what does that do with your oxygens? Now you have an even number. So then whatever it is on the right side, you just have to divide by 2. So what is that? 16 and 10 is 26.
Oh, yes, that's about right.
So you'd have to divide that by 2 and it gives you 13. Okay? So if we have an alkane where it's an odd number, well then, hey, we don't even have to do anything to this. We can just jump over to this side. We can put a 7 right there. What won't be even? Okay? An alkane means these carbon and hydrogen bonds are single bonds, single bonded.
Is the bottom one?
That's an alkane as well. Okay? So then, now let's look at our hydrogens. You've got 16 on the left. How do we get 16 on the right?
Put an 8 over there.
Okay? So this is where we were going wrong in this prior example. But when we look at this, and if you have to write these down, there's nothing wrong with that. 7 times 2 is what?
14.
And 8 times 1? So that gives you what? 22? So then 22 divided by 2 is?
11.
So that's what we mean when we want you to recognize that, is that when we're dealing with alkanes, and this is an even number, you're going to make things a lot easier on yourself when you double that right away. So there must be a reason that we're saying alkanes instead of alkenes, or else we wouldn't bring that up. Well, since you brought it, well, you did, and I did, so we'll just go ahead and continue with that. So we'll return in just a moment. Okay, so we have something fairly similar here, but notice our hydrogens are 2 less now. So these are alkenes now.
Because there's a double bond.
There's a double bond in there somewhere. So which reaction, now a lot of these processes, yeah, I got it, okay, I think that's right, processes are still the same, but which one do you think you want to balance?
The bottom one?
I'm still going to go with the top one. I just
Bottom
like
one
the number
'cause it's
4
not
and 8.
Okay,
Just like it.
so who spoke up first, the top or the bottom? Same? But, okay, so you spoke first. Which one would you want to, do you think you want to do the bottom one?
Yeah.
Okay,
Is
well,
it easier?
I don't know. We'll go ahead and take a peek. Okay, so now if we follow the same logic here, we got 7 and 1. What would we do here?
Put a 7 there?
Okay, so we got 14 here. How do we get 14 over here?
Times it by 7.
Do we see a problem? How many oxygens are over there?
1. Oh.
We got 21 over there. Okay?
Oh.
So you double everything.
So when it comes to alkenes, okay, you're going to make things a lot easier for yourself if it's an alkene, not an alkane, but an alkene, that you're going to want to double this one right away. Okay? So 2 times 7.
14.
Okay? 2 times 14.
28.
So that must mean we just have to put a 14 here. We don't really have to do a whole lot of complex math. I suppose you could say that, which this really isn't that complex. But these numbers do get to be a little bigger. 14 times 2. And 14 times 1. Is that 42? So then what's 42 divided by 2? Blackjack. You win.
Yay.
Blackjack. Okay? So with this alkene here now, okay, let's say, well, we're just going to do human nature. 4 carbons. This didn't work the last time. Let's see how the math comes out now. So let's look at our hydrogens. We've got 8 and 2. So we have to put a 4 here. So then 4 times 2 plus 4 more. So now that works out. Okay? So the next question you might have is, well, how do I know if I'm dealing with an alkane or if I'm dealing with an alkene? Well, from physical science, okay. Oops. So what I want you to do is pick out a number that is 3, 4, or 5.
Shouldn't it be 6?
4.
And then
Okay, so 4. So if we put, if this is an alkane,
4 times 2.
and this is an alkene, okay, so you said 4. So that must mean that 4 we're just putting in for N. So we already know that this is an alkene. Because why? Because we told you that. Okay? So we put 4 in for N and put 4 in for N here. How many hydrogens do we have? So that matches up with that. So we know that this is an alkene now. Because if we do this as an alkane then, same thing, put N in, put 4 in for N. Okay? Now put 4 in for this N. 4 times 2 plus 2 more. Now we know we've got an alkene, and that's what it was earlier. That was a 10. Okay? So if your hydrogens are double the number of carbons plus 2 more, you know that that is an alkane. But if it's just double the number of carbons, then you know it's an alkene. So that's why some of these concepts, they build upon one another. And if we choose, I don't know what's going on. It looks like some of us are having early turkey or something. It's because we can, do you know what tryptophan is? Tryptophan is an amino acid. That's something that we do talk about in biochemistry. You can actually draw the amino acid tryptophan if you really wanted to.
Is that what we get when we get super sleep?
That's what that's, I don't know if that's what a myth maybe. I don't know how accurate that is. But I'm just looking out at the audience and it's just like we look like blah.
I'm just like super tired, and I don't know
It's just
why.
like, it's the last 3 class periods. We got holiday.
Today's only Tuesday.
Yeah.
Yeah, they're always,
You still have 3 days yet this week. That's the type of mind frame you got to do.
But you gotta get the nice nap in after school, stay up till 2. You gotta get that
Okay.
good game in.
So, any questions over this? We will pick up with this next time, next week. Okay? When we come back, it'll be December 2nd. So, 2nd, 3rd, 4th, 5th, and 6th. We'll probably have your first paper handed out on Tuesday, the 3rd, and we'll continue pushing forward. All right, that's all I have. We'll catch up to you next time.